And this is the second iteration, which looks really good. And let's see the time. So you see, it took around 16 seconds. So even with using control net, you are able to get this fast images, which is really good. So the idea is that no matter whichever workflow you will choose, you will get faster images, okay? Hello everyone, welcome back to my channel. I am Kedar, and on this channel we talk about design, architecture, parametric design and generative AI. And in today's video, I wanted to talk about the Nunchaku models for ComfyUI, which basically allows you to create image much faster than the GGUF models without losing out on quality. And the paper that talks about Nunchaku models is this paper, which is SVDQuant, Absorbing Outliers by Low Rank Components for 4-bit Diffusion Models. And this paper was released this year, 3rd of March 2025. And if we see the cover of this paper, they're focusing on Flux Qwen model because that was the first Nunchaku model that ever came up for the Flux Qwen model. And as we know, the developer version of Flux Qwen is around 22 GB, which takes around 111 seconds. And the tests they are carried out here are on a 16 GB 4090 laptop. And what they're saying here is that using an SVDQuant, they were able to reduce the size of the Flux model to 6.5 GB and the generation time to 13 seconds. And trust me, this does work. You are able to see the times that we were using SDXL, and you sometimes wonder, are we using Flux model or SDXL model? And the middle two models are again some different quantization that they're comparing to, where in the third one, the image generation time is similar to the SVDQuant, but the quality of the image is really bad. And in the second one, while the image quality is good, the generation time is way more. So what they're saying is using SVDQuant, they were able to reduce the model size by 3.5x and generation time by around 8.7 times. Okay. Now let's see the abstract of this paper. And I'm going to highlight certain portions of this paper which I felt was important. Of course, you can read the entire paper. It's really interesting. So in the first line, they are saying that diffusion models can effectively generate high quality images, which is true. However, as they scale, rising memory demands and higher latency pose substantial deployment challenges. And this is true. We have seen that while SDXL had 5 GB models, Flux has 22 GB models, and now Qwen we are seeing 40 GB models. So it is getting really hard to use these models on consumer grade GPUs and CPUs. Then they're saying in this work, we aim to accelerate diffusion models by quantizing their weights and activations to 4-bit. Now, 4-bit means something that can run very fast. So we have 4-bit, 8-bit, 16-bit, 32-bit. And for our simple understanding, let's say that with 4-bit, it can generate faster. Yes, there is a loss of accuracy. But right now, let's understand that if you can quantize it to 4-bit, it can run faster. And further, if you go down in the abstract, they say this. To address this, we co-design an interface engine Nunchaku that fuses the kernels of the low-rank branch into those of a low-bit branch to cut off redundant memory access. And now things start getting really complicated. Like we have no idea what is low-rank branch, what is a low-bit branch. We have no idea about it. But I will try my best to explain this as simple as possible, but I am not an AI engineer or a person from computer science background. All I love to do is to read these papers, understand what is happening in the backend, so I can prompt better, download things that work well on my computer than crashing it. Because sometimes I have noticed if I just download without noticing what is the size of this model, ComfyUI crashes. So I find reading paper really helps, not just to do better images, but to also work better with ComfyUI. Okay, enough about what I do. But the key line in this abstract is this, which says absorbs these outliers using a low rank branch. Okay, right now we have absolutely no idea. So if you scroll down on the paper, they say, for instance, NVIDIA's Blackwell tensor cores introduce a new 4-bit floating point precision. Now these Blackwell tensors are the 50 series graphic card released by NVIDIA, doubling the performance compared to the FP8, which were the older series graphic card, maybe 40 series, 30 series. Therefore, using a 4-bit inference to accelerate diffusion model is appealing. And that makes sense. If they're making model that is going to be future proof, they need to figure out how they can work on the latest hardware. And I absolutely love when software and hardware can merge. Really nice. Okay. Then later they say, in this work, we focus on quantizing both the weights and activations of diffusion model to 4-bit, this challenging and aggressive scheme is often prone to severe quality degradation. So what they're saying is when we quantize a model to 4-bit, there is going to be a quality loss. And this is true. We have seen this with GGUF models. I will link my previous video here which talks about GGUF model versus the developer version of the model. But just to understand, generally when you quantize, you do see a severe quality loss. And we saw that with the Hydream model and the Flux model. Then they are saying existing methods like smoothing, which transfer the outliers between the weights and activations, are less effective since both are highly vulnerable to outliers. Okay, so clearly we are seeing a pattern here of 3 words, which is weights, activations and outliers. And if we understand these 3 concepts, this paper can be understood. Okay, and by now most of you might know what is weights and activations, but I'm going to go back to the diffusion process, which is where we understand weights and activations. So when we are training a model, the first step is always going to be collection of image and text pair. That goes in the diffusion process where a noise is added and removed and we get a trained model. Okay, if you want to know in detail how diffusion process works, I will link my natural prompting video here so you can see. So in the diffusion process, there are chances that in the first go you might never get a good model. Okay, this is not aligned. OCD. Okay, ignore it. So there are highly chances that you might not get a good trained model at the first go. You might end up getting noisy model. So during this process, AI needs to constantly change certain numbers until we get a good model. And that is what weights do. So weights are numbers that constantly keep on changing until we get a good model. Okay. Now who is communicating this? Somebody has to tell, right? Are we getting a good model or a bad model? That is what activations does. So activations are like signals or communicators that tell what is happening. And activations are temporary. So while weights are constant numbers, activations are like pulses. They come and go. So they are part of the training process as well as the image generation process. So basically you can imagine weights as knobs. So imagine you have a musical instrument. You keep on changing these knobs until you get a good music. That's what weight does. And that is why most of these models are called open weights model and not open source model, because you can tweak the weights for the fine tuning of the model, and that's why it's called open weights and not open source. And activations are basically signals or communicators that communicate every time during the diffusion process training or in image generation. Okay, so I hope it's clear what are weights and activations. Now let's see the third point, which is outliers. Now when we are doing a diffusion training process, we would ideally like to see this kind of a wave graph because it is easier to quantize, but that's not, it's not an ideal world, right? So generally we see this kind of wave where sudden we have these spikes which are called as outliers. Now you might be wondering, why do this outlier occur? So for simple understanding, let's say we want to create a training data set of trees and we have hundreds of trees where all of them are almost green and there are 2 trees, one is pink and one is white. So this sudden rarity is what causes this outlier. Okay. For instance, let's say you want to create a training data set for architecture. The first, second and the fourth image almost look similar. They're very pastel. But the third image it has a lot of details, a lot of characteristics and rarity. So this is what causes this spike in the training process. And what they want to do here ideally is to separate these outliers and then quantize it so that we retain the outlier characteristics as well. Okay, so I've tried to make it much more simpler for me to personally understand, and this helped me, so I'm going to share that with you. For instance, let's imagine Kedar, me, wants to have a weight training goal where he wants to lift 5, 10, 20 and 50 kg. So suddenly there is going to be this massive spike. Okay, let's not go in what I can lift right now. But if I can connect this weights, activations and outlier to a human body, this is what it would look like. So weight would be the muscle pump. For example, if I have to lift a 5 kg, I don't need to use entire weight. But when I have to lift 10 kg, then I have to use more weight. If I have to lift 20 kg, I need to use furthermore. And 50, I'm not sure if I can lift it. But imagine these muscles as the weights that you keep on constantly tweaking. And the activations are the nervous system. So that can communicate my brain, okay, is he able to do it? Can he do it? Can he not do it? So, and then my brain says that, okay, he can't, whatever. And the outliers is this 50 kg weight which I can't really lift right now, okay? And these outliers exist both in activations and weights. For instance, if I have to lift this 50 kg, my nervous system has to communicate to my brain that, okay, is this muscle able to do it or no? So this outlier exists for both weights and activations. And why I'm saying this? I'm saying this because in the paper they mention for general quantization, they only quantize the weights and never look at activations. That is why they say that sometimes the image quality drops drastically because they don't quantize both weights and activations. Okay, so let's read further in the research paper. So here they are saying this challenging and aggressive scheme is often prone to severe quality degradation, which we already saw. Existing method like smoothing, which transfer the outliers between the weights and activation, are less effective since both sides are highly vulnerable to outliers. So that's what I'm saying. Both of these weights and activators do have outliers. It's not like only one part has it. Okay. So in general process, what happens is that the lifting goal itself is reduced. So if I divide all of these numbers by 5, so it becomes 1 kg, 2 kg, 4 kg and 10 kg. But my goal is not achieved. So the details or the rarity is not going to be captured and Kedar is sad, and that is not good. We need to see how to make Kedar happy. So let's read further in the paper and let's see if Kedar can be happy. So if you go further in the paper, they say next we present SVDQuant, which is their quantization method, a new quantization paradigm for diffusion model. Our key idea is to introduce an additional low rank branch that can absorb quantization difficulties in both weight and activations. So what they are saying, let us introduce another container in which we can dump all these outliers both from weights and activations. So what happens is that my lifting goal now has been split up into 5, 10 and 20 kg, which I am able to. I don't know if I'm able to, but fine. And then the 50 kg, which is a spike, has been separated into a separate new branch. And now this separation is what is called a low bit branch and a low rank branch. If you remember earlier in the paper, there was something called as a low bit branch and a low rank branch, which Nunchaku is able to fuse. So this is what it is. The low bit branch is what is something that is generic and does not have any rarity, but something that is super rare and gives this spike or outliers is this low rank branch. Okay, and let's see later what they're saying in the paper. So later they say our core insight is to introduce a 16-bit low rank branch to further migrate the weight quantization difficulty. And then they're saying the low rank branch operates at 16 bits, allowing us to quantize only the residual 4-bit, significantly reducing outliers and magnitude. So what they are saying, generally what happens is this entire thing gets quantized to 4-bit. What they want to do is split this. So the generic parts get quantized to 4-bit and the rarity or the outliers get quantized to 16-bit. So by retaining the 16-bit versus 4-bit, you can still retain the characteristics or the rarity of these outliers while the generic parts can be reduced substantially. Okay. So now what happens if I quantize this separately, I can divide the first one by 5. So I get 1 kg, 2 kg, 4 kg and the 50 kg I can divide by 2. So I can retain 25 kg. Okay. So this is how they are trying to understand this. And when I understood this, I kind of had goosebumps. Like I was like, how do you come up with these ideas and concepts? It's absolutely fascinating. Okay. But now what happens is that Kedar is confused because now he has two muscles, one that is quantized to 4-bit and the other one that's quantized to 16-bit. And if he has to lift or generate images, he has to go back and forth between this. Okay. And this is where Nunchaku comes in. So further, when you will read the paper, you will see, although the lower rank branch introduces negligible computation in theory, running it as a separate branch incurs large latency overhead, approximately 50% of the 4-bit branch latency. So what they are saying, yes, even though we have quantized this to 16-bit, running it as separate will not give us faster generation time, and that is where Nunchaku comes in because it can fuse both the low rank and the low bit. Now we know what is low rank, we know what is low bit. Okay, now let's go further. So basically what's happening is now I have two muscles, one that is trained for lightweight 1 to 4 kgs and one that is trained for heavyweight around 25 kgs. So you can imagine this lightweight at the generic parts of the images and the heavyweight as a specific or detailed parts of the images. For instance, let's say I want to create this super highly detailed image, but I have two parts. One is this generic and one is the detailed part. So without Nunchaku model, there is going to be constant back and forth. So the generation time will increase constantly. So what they're saying is that we need to fuse this, and that is done using Nunchaku model. So let's read further. By fusing the down projection with the quantization kernel and the up projection with the 4-bit computation kernel, the low rank branch can share the activations with the low bit branch, eliminating the extra memory. So we know what is low rank and what is low bit. So here they are saying there are some part that can be shared by both of these, which the activations can take it, because activations are the signals which will help in creating the images. So as long as the activations can be shared, they both can work together. So rather than going back and forth constantly, now you can simply use this in one go and you get the final images. Okay. And now let's see if Kedar is happy, and looks like Kedar is happy. I mean, the AI made it too happy, but anyway. So is the lifting goal achieved? So my goal was to lift 5, 10, 20 and 50, which was the outlier. Now what we did, we separated into low bit of 1, 2 and 4 and a low rank of 25 kgs. Okay. Now with SVD and Nunchaku, the total comes to 32. If it was a generic method, the total would come to 17. So yes, there is a quality loss, and this will always happen. No matter what quantization method you do, there is always going to be a quality loss. But because they were able to separate those outliers, they were able to retain more details in the images than to flat quantize it. Okay. So this is what this paper is about. Basically, SVDQuant is the quantization method and Nunchaku is the engine that runs both of them together. Okay. So I hope it's clear, and if it's still not clear, let me know. And further in the paper, then they want to compare their own models with the other models. So here they have created Nunchaku models for Flux, FluxNel, PixArt and HTXL Turbo, and you clearly see they are able to get good images, and trust me, the image quality is really good. There is always going to be some loss, which we'll see later on. And later further in the paper, they also say that your own LoRa's can also work with Nunchaku models. I have had a hit and miss with this. So if there is a generic LoRa, it does work, but sometimes if there was a specific LoRa, I did have a problem. If you have worked with Nunchaku plus a specific LoRa, let me know, maybe I am doing something wrong. And if you see the conclusion of the paper, it reads what we saw so far. In this work, we introduce a novel 4-bit post-training quantization paradigm, SVDQuant, for diffusion models. It adopts a low-rank branch to absorb the outliers in both the weights and activations, easing the process of activation. So we clearly know those outliers are separated out, those go to 16-bit, rest of it go to 4-bit. Our inference engine Nunchaku further fuses the low rank and the low bit branch kernel, reducing memory usage and cutting off redundant data movement overhead. So the back and forth movement that would have happened between the low rank and the low bit is reduced using Nunchaku models. Extensive experiments demonstrate that SVDQuant preserve image quality, which is true. Nunchaku further achieves a 3.5 reduction in memory usage over the original 16-bit model and the 3x speed over the W4A16 on an NVIDIA RTX 4090 and 5090 GPUs. This advancement enables the efficient deployment of large-scale diffusion models on edge devices, unlocking broader potential for interactive AI applications. Okay, and that is what we saw. So basically there are two steps. One is SVDQuant for quantization and Nunchaku for running them. Okay, now before seeing what do we need to install, I want to tell you the limitations of this, because I don't want somebody to watch the entire video and see that, oh no, this can't run on my CPU or GPU. So first, let's look at the limitations, then look at what to install. Okay. And the first limitation is that you have to constantly install and uninstall inside of ComfyUI. So you can imagine with every new version of this custom node, you will have to always install, uninstall, because the Python keeps changing. And if sometimes it does not work, then you have to install ComfyUI all over again. There are other ways how we can do it, but this is one of the limitation. The second limitation is the minimum configuration. Now I have tried installing Nunchaku models on my 3066 GB VRAM laptop. It did not work. It said out of memory. I found this website which kind of gave minimum requirements. Of course, this is for Flux model. The Qwen model itself is 11 GB. So you need to at least have 10 GB VRAM with the minimum 16 GB RAM. So that is one of the major limitations of the Nunchaku models, having 10 GB of VRAM plus 16 GB minimum of RAM. So if you don't have this, of course you can use it on the cloud, but it will not work on your computer. I'm sorry, I don't know what else to do, but it won't work on your computer. Okay. And the third thing is that there is always a loss of quality, and it depends from model to model. With Flux, I have seen that there is certain blurriness. With Qwen, I did see slight color dullness. So for instance, if you see this both cat examples, you look at the forehead of the first cat, it is much lighter than the forehead here. So you see there is a color difference with the Nunchaku and the GGUF model. Similarly with the car here, you see the headlight, it looks very plasticky, whereas this headlights here have more detail. Or in the third set of images, see this cup of lentils. So this one is blurry, whereas this one has more details. So the quality loss is inevitable. That's why I was also not able to lift 50 kg, which was my goal. I came to 32 kg, and I think that is fine. That is fine. For the time it can generate, it is really good. So these are the limitations. One is going to be constant installing, uninstalling. Second, you need to have a certain minimum configuration of your computer. And third, there is going to be a quality loss. And now let's see what do we need to install inside of ComfyUI to get this Nunchaku models running. So let's see installation guide. So here there are two methods which I have seen people use. The first method is you install another ComfyUI, let's say somewhere in your drive, and then you extract the models on that particular folder. So you have multiple ComfyUIs running with every version of Nunchaku. I don't like to do that. What I like to do is I like to fresh install ComfyUI with Nunchaku, and that's what I'm going to show you. So I'm going to also show you how to install ComfyUI because there are some things that have changed, plus installing the Nunchaku custom node. And ideally, I would recommend everyone to install ComfyUI fresh every 2-3 months so that you don't have a clutter of Python crashing and things like that. And you also over the time, you know which custom nodes to use, to not use, so you don't install the same custom nodes over and over again. So first, let's see how to install ComfyUI, which most of you might be familiar with. So to install ComfyUI, we need to go to this website comfy.org. Then you can say download. Now there is Comfy Cloud also, which I already spoke about in my previous video. And then once you click on download, it will ask you whether you want to download for Windows or Mac. And since I have Windows, I'm going to click on Windows, and a file of around 117 MB will be downloaded. Now with ComfyUI, I generally like to have two separate things. One is where the setup file is, and one is where the models and everything are located. So you can go in your computer. I generally prefer to download on C drive, and in my C drive, this is how I have the setup. So I have ComfyUI setup, which has all the setup files, and I have ComfyUI, which has all the models, LoRa's, everything that is there. And then you need to simply say install. So after installing, it will ask you, do you want to run ComfyUI? I generally tick it and click on finish. So then it will get started with the process of creating all those models and all the folders. So then you'll be greeted with this page. Just say get started. And if you have an NVIDIA GPU, it will automatically detect it. You don't need to do anything. All you need to do is simply press on next. Then here you need to specify the folder. Now like I said, I have two folders, one with ComfyUI setup, which was the setup file, and here I simply create C drive ComfyUI where all the models, LoRa's get saved, and then I press next. And then it will ask you, do you want to use automatic updates and usage matrix? I generally keep both of them on and simply press on install, and some things will start happening in the background. Just wait for 5 to 10 minutes and you will be greeted with this window, which means your ComfyUI is installed. You are good to go. Then next, let's see how to install Nunchaku models, which is really simple. So in the ComfyUI space, click on this manager. Once you click on manager, this window will pop up. Then say custom nodes manager. Once you click on this, in the search bar, just type Nunchaku, and you see there is something called ComfyUI Nunchaku. Simply press install, and once you install, you will get this window. I generally like to select latest and not nightly, because nightly are the ones which have the beta versions as well, which have more possibility of things getting crashed. So then I click on latest, then I say select, and then the Nunchaku custom nodes gets downloaded in the background. Then you need to restart it. Ideally, if you have installed ComfyUI for the first time, I would recommend you to restart your computer as well. Really, it helps. Okay, then the next step is we need to install the Nunchaku custom nodes. Yes. Unlike other custom nodes where you download it, you can easily use it. Here we just downloaded the Nunchaku custom node, but we haven't installed anything yet. So what you need to do, then you need to click on templates inside of ComfyUI. Then below templates, you see extensions. Here you can simply say ComfyUI Nunchaku. And in templates, you can always see whatever custom nodes you have installed. And if that custom nodes come with certain files, it will always be seen here in the templates tab. Okay. So if I click on ComfyUI Nunchaku, then I get all the files that it comes with. So then I say install wheel. So you need to click on this install wheel. So here we need to change certain things. And what I like to do here, I like to keep the version as latest. Developer version I say none, and mode I say install. Once you select all this, press on run, and once you press on run, pray to the gods that it works, and if it does not, then you need to uninstall this again and then install it again. There is no other way. So keep praying when it is installing. Very important. Okay. So you press run and you will see in the background it says checking for new version from internet sources, successfully created updated Nunchaku version, and you will get this message, success install Nunchaku, and done. You are absolutely golden. Now you can create Flux or Qwen images in HDXL speed. Life is going to be great. Okay. So this is what you need to see. Now let's see what models we need to install. Okay. So again, I'm going to go back to templates. Then we go to again ComfyUI Nunchaku. Now here you can select whichever file you want to work with. Maybe it's flux.1dev or maybe it's Qwen image. Okay. In this case, I'm going to select Qwen image and you get this pre-fed workflow. Now here what is important is you need to read this box. Ideally, read all of these boxes before you start working on any of these workflows. But let's read this box. So what does this box say? With Nunchaku, you get two versions of the file. One that is compatible with a 50 series GPU and one that is for other GPUs. So if you remember in the research paper also they said for Blackwell Tensor, which works with 4-bit unlike others. So they have created two separate versions of this Nunchaku models. So in my case, because I have RTX 4090, I will need to select a model that has INT4. Then below they say R128 models provide higher quality than R32 but run slightly slower, and I want absolute fast. So I'm going to select the R32 version of the model. So I need to look for INT4 because I have a 4090, and I need to look for R32 because it is faster. So if I go to this link where you can download the Qwen Nunchaku models, so you see the first 6 ones have FP4, which means they will work on 50 series card, not on my computer. I need to download the next 6 one. Out of these, the first 3 are R128, which I don't want. I want R32. So I need to select between these 3 models. Now the first one is a lightning model with 4 step. The second one is a lightning model with 8 step. And the third one is your total model, which will take at least 20 steps. So I'm going to ignore the second and the third and the download the first one because I need the fastest model. And this model is around 11.5 GB. So that's why I said the computer configuration is really one of the limitations with Nunchaku model, because imagine even if you have an 8 GB card, it will take more time. Okay. So I'm going to download this. And where do you download this? So you download this inside your C drive, ComfyUI models, diffusion models, and you see I have a Flux Nunchaku folder, a Qwen Nunchaku folder. You can create separate folders, and that is where you can download this model, and then you can simply run this. Okay, and now let's see how to run this inside of ComfyUI. So I'm going to compare this with the GGUF model as well. So the first one is going to be for Qwen image, and this is the workflow. Okay, you don't need to really copy this workflow. All you need to do is go to templates inside of ComfyUI, then go to ComfyUI Nunchaku, and then select any of those pre-fed workflows. You will basically get this same workflow, okay, which basically has the Nunchaku model, your prompts, the image size that you want, K-sampler plus VAE, and your output. And this I want to compare with the generic Qwen model, which is using the GGUF model, where everything remains the same. Only thing, you add a GGUF Qwen model using a 4-step lightning LoRa. So that is the only thing that changes. Everything else remains the same. Okay, and now let's look at some of the images that I have created. Again, to have consistency, I have kept the same seed of 100. So both the Nunchaku version and the GGUF model give the same images. And here are the results. Again, I have tested it for the same 4 prompts. The first one is a parametric building. Second is a napping ginger cat. Third is an origami landscape. And the fourth one is an exploded thali. And the prompts are listed on top. So the first one, clearly what we need to see here is the generation time. So with this one, it took 42 seconds with the GGUF model. And with the Nunchaku model, it took only 16 seconds. I told you, you get closer to the HDXL generation time. It is really good. And in terms of quality for this one, yes, I do see a little bit of dullness. For example, you see here, there is slight dullness here. in compared to the GGUF model. But I think, like I told you in the earlier limitation, this is going to happen. There is always going to be some trade-off with these quantized models. Now let's look at the second one, which is the napping ginger cat. Again, there is a slight decolorization, but you see the generation time, it is 50% less. That is really, really good. One of the things that I don't like to do is sit in front of my computer, wait for what is happening, but this is really good. And let's see the next one. Again, you see a little bit of dullness in the first image in compared to the second one, but the generation time is 50% less. Again, we can always upscale this. This is not something that can be rectified. This is the model right out of the box. We can always upscale this, infill, tweak things, but I'm just only showing you that there is going to be some dullness in the images. And then in the next one, the exploded thali, again, both of these look really good, and the generation time is 50% than the GGUF model. You know what would be a nice experiment is to post this online and ask people to figure out which is the GGUF model and which is the Nunchaku model and what is the time generation that is done. That would be really interesting. Okay, so this is with Qwen, where you see a little bit of dullness in the images, but that is something we can always rectify in upscaling. Okay, and now let's see the results from Flux.1 dev. Again, simply go to ComfyUI, go to templates, go to ComfyUI Nunchaku and select the Flux.1 dev file, and you will get this. Of course, they will not be nicely organized like this. They will be overlap. You need to split it out. But here in this case, what is interesting is that you have the Nunchaku version for the text encoder as well as the model. While in Qwen, we only had the Nunchaku model for the main model and not for text encoder. Maybe that's why Qwen is not that faster. I'm not sure. But anyway, the workflow here is that you have the Nunchaku model, you have the prompts, you have your image resolution. This everything is just a case sampler that has been separated, and you have the output. So this is with Nunchaku, and the Flux1 dev workflow for GGUF model is simply like this. So you have your Flux model, could be anything, Q6K in my case. You have your prompts, you have the image resolution, you have your case sampler plus VAE and the output. Okay, and now let's compare the results, and clearly you will see that with the GGUF model it took 53 seconds, whereas with the Nunchaku model it took only 12 seconds. I have no idea how they have able to do it. I mean, I know what is the process behind it. We just read the research paper, but it's still mind blowing to see this happening. 12 seconds, absolutely nothing. Okay, and the quality is not that bad at all. Yes, like I told you, with Qwen there is sometimes dullness in the colors, and with Flux I've noted some blurriness, but it is fine. For 12 seconds, what else can I ask for? Okay, imagine if I do 12 seconds image generation, if I do around 30 seconds of upscaling, entire thing is done under a minute. And here with Flux GGUF model, it's only 1 minute for image generation, then 2 minutes for upscaling. Now let's see the napping ginger cat. Again, the results are quite similar, but here again you see 55 seconds versus 16 seconds. That is so fast, so good. Again, if I would show you these two results without telling you which is from Nunchaku, which is from GGUF model, you would not even recognize it. So clearly whatever they have done has worked out. One thing here to note is that with Qwen model, the model size was around 11 GB. This is around 7 GB. So this can potentially work even if you have a 8 GB VRAM card, while the Qwen model might not work. Okay. Then let's see this origami landscape. Again, both of them really same result. See the time, 15 seconds versus 55 seconds. Really amazing result. And like I was said, there is some blurriness that you will see. If you see here, there is a little bit of overlapping and blurriness with the trees, while that is not seen in the GGUF model. But again, this is very negligible. If I compare them side by side, that's when I see. If I would not even compare, I would not even notice it. And then with the exploded thali, again, both of them give really good result. 15 seconds versus 55 seconds. Okay. So basically, if I take an overview, with Qwen Nunchaku, you get a 50% reduction time. On an average, without Nunchaku, it's around 35 seconds. On an average, with Nunchaku, it's 16 seconds. Now with Qwen, because you have a distill LoRa, that's why you're able to get 4 steps. With Flux, we don't have a distill LoRa. All the 20 steps has to go. But even with 20 steps, we see a 75% reduction in time. So what was 55 seconds without a Nunchaku model is 14 seconds with the Nunchaku model. I think it's really absurd. Now let's see how to do this in ComfyUI quickly. I mean, I already showed you, but if you want to see how it is done, I'm going to show you a quick tutorial on ComfyUI, and then we will end this video. Okay, so I've started ComfyUI, and now let's run this Nunchaku models. So the first step is you need to go to templates, like I told you all. Then go to Comfy and Nunchaku. So first let's test for Flux.1 dev. There is too much of L and S and my Lisp is coming up. But anyway, let's find Flux.1 dev. So we select this one. Okay, I hate this. Please, ComfyUI team, please take 5 minutes and organize these files. It's very annoying that all of these are overlapping. Okay, anyway. The first step is you need to, of course, download the model. I have already downloaded the model. So I'm going to select the Flux Nunchaku model. And here, in this case, they're using 2 LoRa's. We don't need that. So I'm going to delete this, delete that. And then, of course, you can keep it neater. And then you can always change the resolution that's here. And let's add a simple prompt, a cat. Okay, that's it. And let's see if it runs. I'm going to say run. Right now the steps are only 8. Ideally this has to be 20. So I'm going to make it 20 and let's see if this works. So it takes a lot of time in the first generation because it has to upload everything. Okay, and this is the result. I just typed a cat and you get this. With the first generation it's going to be longer because it has to upload all the files on your CPU and GPU. But now it will be much faster. So right now we see the first one took around 61 seconds. Let me add another prompt. So I will add this prompt. I mean, you can pause and read it and I'm going to run this. And now let's see that result. So this is the prompt that I added and the result looks like. Now when you again keep on changing the prompt, the time will be higher. So you see now this is 54 seconds. But now I will not change anything. I will just change the seed value and I will run this. Okay. Yeah. And now let's see the time. So you see now it took only 14 seconds like I showed in my presentation. So of course, whenever you change the prompt, because it has to go again through the text encoder, it is going to take some time. But if you simply add prompt, create multiple iterations, it is going to take less and less time. So right now you see with the K sampler, it took only 13 seconds and the entire process took around 15 seconds. Okay. Also, you have to understand right now I am running multiple things on my computer, including PowerPoint presentation, ComfyUI, recording things. So there are 6-7 apps running. So there might be a little bit of a change in the time generation, but it does work. Okay. So this is with Flux.1 dev. Now you might be wondering, where do I download this model from? So it's very simple. Just go to Google and type that name. Okay. So I've typed this in Google. And generally you get multiple links. So you see the first link and there is link number 3. So if I open the first link and if I go to files and versions, you will see that the nomenclature is not there. So I don't really know what I'm downloading. So I don't like to go to that link. What I like to do is I like to go to this third link. Always the link that is next is what I select. And now here you will see with the model card, the same thing is represented, SVDQuant. And if I go to files and versions and you see we have both the versions, which is FP4, that is for 50 series cards, and this is for INT4. So that's what you have to do. Always write the name. Now here if I say depth, so there are a Nunchaku model for depth map as well. And I go to this link, then I go to files and versions. And here again, one model you get for 50 series cards, you get one more model for INT4, which is cards below 50 series. Okay. So that's how you find on Google and just download it in your diffusion model folder. Very simple. Now let's jump back to ComfyUI. Okay, so this works, and in this video I don't want to combine multiple workflows. I just want to show you how to make this Nunchaku models running. So again, you can go to templates, again go back to Nunchaku, and let's say what else we can check here. Okay, let's say we check this. Nunchaku Flux.1 dev ControlNet Union Pro 2. Now you might be wondering, the Flux Nunchaku came in, I don't know, April or June or something. Why am I making the video now? Okay, so I was waiting to get the Qwen image Nunchaku for me to use it. I do not use Flux model because I find problem with the licensing. That's why I have not made Flux videos. A lot of people ask me why you don't make Flux videos. It's okay for me to teach, because then it depends on them what they use the licensing for. But I would like to make videos on this channel, the model that I work with, and Flux is not the model that I work with. I have been using HDXL for the most part, and now I'm shifting to Qwen because I'm okay with the licensing. And to make a video on licensing, to explain you why I'm not using. Anyway, that's fine. So right now with ControlNet Union Pro 2, so I already have this. So you see Flux Union 2, it's using the depth map, which is fine. Now here I'm going to select an image. Let's say this architectural image. I'm going to copy the paste the same prompt. I will select the Flux Nunchaku model here and change the width and the height. So to 1024 by 1024, and seed, I will keep it to randomize. Right now we start with 100, and then you can take any random seed, and then we will run this. Okay, and let's see the result. So clearly this was the input image, and using a depth map you do see the same kind of composition has been followed. Of course I'm not changing more of the control net values, you already know how to do that. Again, the first generation time took around 57 seconds. Now if I run this again, you will see it takes much less time, and this is the second iteration which looks really good. And let's see the time. So you see it took around 16 seconds. So even with using control net you are able to get this fast images, which is really good. And this was the input, this is output. I absolutely love this. I absolutely love this. This is so nice. So the idea is that no matter whichever workflow you will choose, you will get faster images. Okay, I'll show you one for Qwen as well. So again, you go to templates, go to ComfyUI and Nunchaku. Qwen is the last one. And like I was saying, for Qwen, you only have the Nunchaku for the model and there is no Nunchaku for the text encoder. I don't know why that is. But anyway, I'm simply going to change the prompt. Then I need to use this. So I've downloaded Qwen both, one for the image editing and one for image generation. I'm going to say the image generation one. And here I need to change the steps because I have a 4-step lightning model and CFG to 1. And now we need to run this. And this is the result. I love the output from Qwen, really good. And the time it took was around 37 seconds. Now if I run this again, it's going to be slower. And this is another iteration of the image. And if I see this time, you see 15 seconds. So the extra seconds it takes in the beginning is for loading the model and not for creating the images. So image generation time is 15 seconds. The extra 15 seconds that go here is for loading the model. Okay. So I'm going to take one more prompt. So I'm adding this another prompt of a cat. Of course, you need to make cats, no? Those are the new viral things. Okay, and this is the result. Look, how amazing Qwen image creates images. Really beautiful. And it took around again 24 seconds. Now if I run this again, so I made another iteration of it, and now we see it takes 15 seconds. So the first run is always going to be longer than the subsequent run. So if I see all the images again that we made, you see this was the first with Flux, 61 seconds. Again, I changed the prompt, so it made 54 seconds, but the subsequent image was 15 seconds. So you see, around 75% less. Then we used control net, which was again 16 seconds. Then we used control net again, which was only 20 seconds. Okay, in between, I had to use this to clear my VRAM. Then we used the Qwen one, again 37 seconds. Subsequent, the next one, half of it. Now this cat one, 24 seconds, and the next iteration of it around 15 seconds. So clearly you do get faster images with Nunchaku model without losing out on quality. If you have that much minimum VRAM, you are good to go. But if you want to explore any further workflows, simply go to templates, go to ComfyUI Nunchaku, and most of the Flux Nunchaku versions are already available here. So if you are somebody who uses with Flux model in and out, you can use Nunchaku version. Just replace all of those nonsense of Flux model with Nunchaku model. You will thank me. With Qwen, we have two models. One is Qwen image and Qwen image edit for editing. Okay. And like I told you, how do you find if you don't know where to find this model? Simply type on Google the name. So if I take, let's say, Flux.1 context dev, and now I need to download this model, which is INT4R32 Flux.1 dev. Simply type this on Google. See that the name of the model that you download is similar to the name that is given here. That is mostly it. Ideally, they link it here. Now here in this case, they have linked it, so I can go to Hugging Face. But if you remember from Flux.1 dev, there was no model link. I mean, ComfyUI people, you also need to update sometimes. Okay. Now let's go back to the presentation and end this video. So now that you looked at how to work with Nunchaku model inside of ComfyUI, it is really simple. Just download the workflow, download model and run it. The problem is that if it is installing or not. If it does not install, please go again back to the installer wheel. Then instead of install, select uninstall. And please remember to restart your computers. A lot of people don't restart computer, and that's where problem happens, because even if you restart ComfyUI, restarting computer is really important. Okay. And to end this video, we need to see what is the conclusion of this. So what is the conclusion? I mean, the conclusion is simple. Go use the model because they are fast and does not reduce quality. But apart from that, there are some things which I thought of, I think would be interesting to share. So I personally feel while the entire year we have been focused on creating a better image editing model and video generation model, Nunchaku model to me feels like a standout development because this makes things accessible for consumer grade GPUs and CPUs, which in my opinion is way important than just creating video generation and image editing model. And I hope to see all of these, maybe CD, maybe WAN, in a Nunchaku format, so we can explore and I don't know, maybe create more AI slops. The next one is that with Nunchaku model, you get back the HDXL speed. This is why I still use HDXL sometimes, because it is so fast for ideation without taking a lot of memory power. So seeing this generation time, especially with Qwen, I am super happy. Then of course it is optimized for speed without major quality loss, which you already saw. Then there is some slight dullness or blurriness, which of course we can upscale it. This is me nitpicking it. It does not even matter. And then this is a great example of when hardware and software come together. Like imagine if we didn't have the 50 series card that are going to be working with 4-bit architecture, we would not even see this Nunchaku versions. So it's really nice. I absolutely love when development happens like this. But I think that's my personal conclusion with respect to model. There is nothing. Just download it, get it running. If it works, you are golden. So that's mostly it for this particular video. I hope you understood how Nunchaku model works, how to download and install it. And if you were able to download it, do comment and let me know how fast you're able to create AI images now without losing on quality. And please don't forget to like, share and subscribe. And if you see this new YouTube hype button in front of my video, don't forget to press that because it will help reach larger audience. And I will see you in the next one. Thank you.